Good morning, everybody, and please welcome. My name is Matteo Ferrari, and I work as a product manager in Opto Engineering. Opto Engineering is one of the few companies in the world that can design, can sell, can manufacture, and can give an assistance in several type of products and services of in a machine vision. Our product ranges from cameras, optics, lighting, software, answering an integration between them, thanks to the experience that the company has in more than 20 years of activity. Today, we will talk about some innovative technologies in the field of industrial cameras. We will first focus on polarized sensor, and then we'll switch to the SWIR technology that permit us to unveiling the invisible. Then we will also talk about the liquid lens technology that allow us to making focus of objects placed at different working distance. Let's start with polarization. To talk about polarization, we need to talk first about the light. The light that is an oscillating transverse electromagnetic wave composed by an electric and magnetic field that propagates perpendicularly to each other and perpendicularly to the direction of propagation. Specifically, the polarization is a geometrical properties of light. And it is a crucial part because, as we've seen here, light undergoes polarization when it is reflected, partial polarization, when it is reflected by a surface. And the type of surface, its chemical and physical properties, determines the reflection we have of the light. Based on this criteria, we have specular reflection or diffuse reflection. Specular reflection is when light is once reflected by the surface, and it is typical for smooth and shiny surface with a high degree of polarization, such as glass, water, metal, and so on. The diffuse polarization, otherwise, is a polarization that we have with a raw surface, such as clothes or paper, that has a low degree of polarization. Well, reflected light, sometimes it is an interference for our system vision. Imagine to want to see inside a car through the glass. And in some cases, in some angles that we will see next, we have reflection that can't permit us to see inside the car. So our goal is to remove the polarization component of specular reflection, and vision system can help us in this task. Two main important magnitudes and physical quantities that are very relevant in polarization are the degree of polarization, that is the physical quantity that describes the amount of the electric wave that has been polarized. So 100% of DOP, degree of polarization, means that we have a full polarized wave. And the 0% polarization wave, it's an unpolarized wave, of course. And this quantity depends on the angle of polarization. Here you can find a graph that shows the degree of polarization according to the angle of reflection. And we have a peak of the degree of polarization at the breast-two angles. To remove this polarization part, we can use polarizing filter that are devices that blocks electromagnetic radiation depending on its polarization. And the output wave that we have over the filter depends on the angle of the waves and the polarization angle that we use. This has a great limitation because we can remove just some parts, just some components of the polarized wave. Because to remove all of them, we will need different type of polarizer. Opto Engineering has developed its cameras, Itala cameras, with the PolarSense technology that use an PolarSense image sensor that combines the great key feature. The sensor is composed by three main parts: the on-tip lens, the polarizer and the photodiode. But the most important part is of the polarizer, of course, because the polarizer is as composed by 4 different oriented polarization filters. And the outcoming wave that we have is defined by the Moore's law that shows the dependence in the angle of the wave is striking the polarizer. In that way, we can combine 4 filters, 4 polarizing filters in just one sensor. Polarized filters and polarizing sensor can have such a variety of application tasks, and it is properly used in high reflective or transparent objects. Here you can see some example. A barcode reading in presence of reflection, that is a barcode inside a plastic bag, or the inspection of the presence of absence of pills and tables in a blister plaques, and the inspection of scratches on transparent surfaces. Now we talk about the SWIR. SWIR is the acronym of shortwave infrared. That is a subset of infrared band in the electromagnetic spectrum that has wavelength between 900 nanometers to 2,500 nanometers. Well, all these wavelengths are not visible from the human eyes, but are more very interesting because they can give us some important aspects of the object we want to see. Opto Engineering has developed its ETALA G series, that is a G-SWIR sensor-based cameras that combines the SWIR properties by the physics with the key advantages given by the SWIR technology, where the main properties of the SWIR that can be used for our vision task are listed here. Well, some materials appear transparent in SWIR, such as silicon. You can see, for example, here the comparison between a SWIR and visible capture of a silicon buffer. Then, water absorbs light at wavelength of 1,500 nanometers. And it is very useful for field inspection and health probe that we will see later in the application. Reflectance and absorbance varies from one material to another, and it gives some important key features and signature spectrum feature of the material. Then SWIR is less prone to obstruction by airborne particles. So in that application, SWIR is used to see between the smoke, for example. The last one is that the objects with temperature above 250 Celsius emit light in the SWIR, so we can get the evidence of the homogeneity of the warm bodies. The SWIR technology that we have used in our cameras is based on the Sony SWIR sensors. And the key advantages that we had with this type of sensor are listed here. The first one is the pixel miniaturization. Traditional SWIR sensor has a wider pixel size because of the technology they used and the bump connection, the traditional bump connection bonding. SWIR technology uses CU-CU direct connection that allows a narrow pixel size. Another important thing is the layer, the in-phosphor layer that is thinner for the SWIR sensors, and it allows easily to the visible light to come into the camera. So with just one camera, we can see also the visible light and the SWIR wavelengths too. We can have 2 cameras in one. Last but not least, SWIR technology also incorporates digital conversion that permits to have a limitation of in-image processing after the sensor. SWIR applications are very, we can have very lot of application in a SWIR. As you can see it can be used for food selection and plastic sorting. It can be seen in a semicon industry because, as we said before, SWIR appears, silicon appears transparent, and it is can be used for wafer alignment and PCBA inspection, for example. But it is also you identifying the flames of a fire through a smoke, for example, or the crop health assessment, or in a pharma industries. I would like to talk fastly about the last technology that we have available with our ITALA cameras, that is the liquid lens technology. Liquid lenses are lenses that are used that use a combination of optical fluids and flexible polymer membrane to mimic the focusing principle of the human eyes. They run thanks to the work of a ring, circular ring, that is moved by a proper electrical signal, current signal control. And the shape of the lens can be changed varying the size of this ring. This technology is very interesting because it allows to making at focus different objects at different planes. And we have the advantage given by the liquid lens technology, but also the advantage given by the solution that Opto Engineering offers with their ITALA series cameras. The advantage given by the liquid lens are that the liquid lens are reliable and durable performance, ensure durable performance, with elimination of mechanical wear, and it also permits repetitive use. They are more robust and dust-resistant system than the other lens that required a particular focus and particular lenses. And also, this type of lenses are less sensitivity to tolerance. The key advantage introduced by Opto Engineering ITALA GEL series is that our cameras don't require the driver, the external driver for the liquid lens control. In this case, the vision system is very, very simplified, and it's obviously noiseless. That is very useful, for example, in medical areas. We can have several applications of the liquid lens technology, and following you will see the integration of this technology with our cameras, of course, but also with different type of optics. For example, we have the integration with focal, with a fixed focal lenses that are ideal for high-speed inspection at different working distance, of course, or the integration with the cell-centric optics that permits an increasing in depth of field, especially in low field of view application. Here in the picture you can see from a PCBA how two different parts of the PCBA can be easily placed at focus in just few milliseconds. Another integration could occur with two liquid lenses. Here you can see the two liquid lenses control with the telecentric lenses for the synergetic control of magnification and working distance, or the integration with the lenses for cavity inspection for whole cavities and so on. So in this case, we need to place focus deeper in the cavity. The last one application is the integration with borescopic probes, for example. Also, all the products that you see from the slides are coming from the Opto Engineering catalog. So I invite all of you to visit us at our booth here at booth 8D48. And the field of use of this application are several, from semiconductor to logistic and packaging for the life science industry and food and beverage. So I really thank you for your attention, and I invite you to our booth. Thank you.
Hello. What with problem with the fog?
Sorry?
Right. My friend actually asked him if it's possible to use your system for a camera when you need it to actually use with the weather when you have a fog and objects through the fog. If you can
Yes,
see it.
it is possible. Do you mean the liquid lens technology? Yes.
SWIR, sorry.
The
SWIR.
SWIR. Oh,
Yes.
the SWIR. Yes, yes, it's possible.
Okay.
Yes,
We can discuss on your station later on.
yes, you can see for this, of course. Thank you.